Okay, this is PSL for Thursday, January 21st, so let's go ahead and get started. Today's PSL is going to kind of focus around the fact that we have the iStep coming up, which is going to be the response with the pencil paper that we did with the Acuity. And really, one thing that I noticed when I was grading the Acuity results is that we as a group as a whole do not put nearly enough detailed description. When you feel like you've been thorough, that's still usually not enough for what they're looking for. So I feel like when it comes to this stuff, just really giving it almost like you've given too much information, you've gone over the top is what they're looking for. So you always want to kind of go for that, which kind of is annoying, but we'll practice that quite a bit today, and you'll get a taste of kind of what I'm trying to say. So this would be an example that they would give you. Solve this equation. This equation is a multi-step, which we're used to, but it also involves fractions. This is an ugly equation. And one thing that iStep wants you to do, and Acuity and all of these standardized tests, what they want you to do is to show all your work. So even if you're a person that's doing it in your brain, try your best to, get as much of it down on paper as possible, because we do give points and credit and stuff like that based upon some of the stuff that you show in your work. So I'm going to start solving this problem. And really, when I solve any problems in PSL or in class or as an example, I always show all my work just to kind of get you guys in the habit of doing that. So I'm going to start by looking at the left side, and the first thing I see is that I have this number right here, 2/3, which is a fraction, and that we need to distribute it to the parentheses. So we're going to take 2/3 times x, which becomes 2/3 x, and then I'm going to multiply 2/3 times 12. Now, depending on if they give you calculators or not, and I don't know if you would have a calculator for this, you would need to be able to do it without using a calculator. So off to the side, they want you to show all your work. You might want to do some chicken scratch. So 2 times 12 on top is 24. 3 times 1 on the bottom is 3. 24 divided by 3 is 8. So 2/3 times 12 is going to be positive 8. And again, this is something that they're expecting you to know how to do. So the more that we practice it, the better we'll be when the time comes. And I know it's not the funnest thing to do, but we can practice it. So now we've got on our left side 2/3 x plus 8 plus 2/3 x equals 4 on our right side. So I'm going to go through and shape code. So here's an x term. Here is an x term. And then for my number terms, I've got positive 8, and over here a positive 4. So now I'm going to combine my like terms so I can see that these two are similar. So I've got 2/3 plus 2/3 x. So again, if you don't have calculator access, you might have to add this on your own, remembering that we keep the bottom the same and then add the top together if we're adding, so it becomes 4/3. So this becomes 4/3x. Bring down our positive 8, and that equals 4. Okay, so now I've got 4/3 x plus 8 equals 4. So I've got the like terms circled again. So I want to move this positive 8 to the other side. In order to do that, I'm going to do the opposite. So the opposite of positive 8 is negative 8, or subtract 8. So I'm left with 4/3 times x on this side is equal to 4 subtract 8. So I'm going into the negatives. 8 is larger, so I'm at negative 4. Now, to get x by itself, it's being multiplied by 4/3. So you need to think of what is the opposite of times 4/3, which would be divide by 4/3. When we're doing this in math without a calculator, the way that we actually do that on paper would be to multiply by the reciprocal. So whatever's on top, you put in the bottom. Whatever's in the bottom, you put it on top. So instead of divide by 4/3, you would multiply by 3/4. So over here, I'm going to multiply by 3/4. And if I do that to that side, I have to do that to this side. So that cancels out that, and I'm left with x equals, and again, they want you to show your work, so I'm going to kind of separate this a box right here. Negative 4 over 1 times 3 over 4. So just going straight across, we want to multiply. Negative 4 times 3 is negative 12. And then on the bottom, 1 times 4 is 4. And we can simplify that. Negative 12 divided by 4 is negative 3. So x equals negative 3. And that is the answer for that equation, for that question. And what I want you to note is when it's saying show all of your work, notice how much work is actually involved in solving just that one problem. Okay, the next question asks us to explain how you know when a linear equation in one variable, so this could be like y equals 3x plus 2, but how do you know when it has infinitely many solutions? So the way that we're going to know this is when, and I lied, this has two variables. Let's do, I can't even think of a good example. Well, anyways, it's when you're solving an equation, so yeah, I can't think of an example, but yesterday, okay, we had one yesterday on PSL. So we had one yesterday that looked like this. P minus 4 equals negative 9 plus P. So say we had that, but instead, I'm going to put that this is a negative 4. So the way that we know when we have infinitely many solutions, and you would need to be able to think of this off the top of your head, is when we're solving for P, we end up canceling out both P's, and we're left with just numbers. And then we have to think about that statement. Is that statement true or false? And if it's true, then it would be infinitely many solutions. Okay, so what I've done is I've gone ahead and I've written out what I was just saying in words, only this time I've put it into writing. So when you move the variable and it cancels out on both sides, you will be left with a number equals a number. So if the statement is then true, like 10 equals 10 or negative 5 equals negative 5, then the answer is going to be infinitely many solutions. I don't feel like that is the greatest description in words of what I was trying to say earlier, but like I said, what they're looking for is that you just, talk, but with your words. Like if you're thinking something, make sure you're getting it down on paper, because I just feel like you can never have too much, but you definitely cannot have enough. That happens so much more often than the other. Okay, part C. So what does it mean when a linear equation in one variable has infinitely many solutions? So say we got, an answer and it said P minus 4 equals negative 4 plus P, and we got that it was infinitely many solutions. So what does that actually mean? What does it mean? P minus 4 does equal negative 4 plus P. So what this means is that if you were to graph this P minus 4 on a coordinate plane and graph this negative 4 plus P on a coordinate plane, that their lines are going to fall directly on top of one another. So that line falls on top of that line, only more perfectly. Yeah, and I'm way off, but you get the gist of what I'm trying to say. So now I'm going to try and express this in words. So here is my description in words. The equations are equal to each other. When you graph them, the second equation will lie perfectly on top of the first equation. And also, I could add to that the reason there's infinitely many solutions is because every point or any point that falls on that line in either direction is an answer that would make the statement true. So go ahead and get that down, and like I said, again, can never have too much writing. This is a lot of writing for math, but this is what they're looking for. Okay, now we have a diagram of Mr. Ford's pond. So the first part says, part A, Mr. Ford notices that the shape of the pond is somewhat like a triangle. Kind of, I guess. He claims that he can approximate the perimeter of the pond without doing any measurement of the actual pond or on the diagram. What assumption would it should say Mr. Ford, would Mr. Ford need to make in order to justify this claim? So we are given some basic information here. We're given this side right here is equal to 25 yards and this side is equal to 30. Other than that, we don't really have anything to work with. So what would we need to assume in order to be able to work with this? Well, the first thing we would need to assume is that this was a 90-degree angle, because then we could use the Pythagorean Theorem to figure out this distance. And the second thing then that we would need to assume because of that is that the pink line that I just drew is about the same length as the squiggly line that actually is the other side of that pond. So here is the description of that other assumption that we need to make. But now that we have these two assumptions made, that we have a right angle and that this squiggly side is going to be equal to that line I put in there, we can use the 25 yards and the 30 yards, and we could probably figure this out. So moving on to the second part, part B. Okay, so let's go ahead and rock this out then, because we've got that a squared plus b squared equals c squared, and we've got an a b, and this can be our c. So if this is 25 and the b is 30, you can set that equal to c squared. So 25 times 25 is 625, and then 30 times 30 is 900, and that equals c squared. 625 plus 900 is 1525 equals c squared, and to get c unsquared, we need to take the square root. So the square root of 1525 is going to be equal to c. So c equals approximately 39.05. So this up here, c, is 39.05. So now to find the perimeter, all you have to do is add up all the outside edges. So 25 plus 30 on the bottom plus 39.05, which is our new measurement. So when we add those all up, we get a total of 94 5/100, and we are in yards. Because we're in perimeter, it's just single yards, so it's 94.05 yards, and that's the answer.